Hello everyone, my name is Zhe Liu. I'm very glad to have this opportunity to attend the conference. The topic of my presentation is Adaptive Weighted Multiview Evidential Clustering. I'd like to divide my presentation into four parts: introduction, method, experiments, and conclusion. Firstly, I would like to introduce the background of our research. Clustering is one of the most important techniques in machine learning and pattern recognition, among which partition-based clustering has always received extensive attention. It can be mainly divided into two types: hard clustering and soft clustering. Hard clustering cannot represent uncertainty and imprecision. Each object is assigned to one and only one group, and the group membership is represented by binary variables. K-means clustering is a typical representative. Fuzzy clustering is the most popular of soft clustering. Each object has the membership degree UIK to each group. A well-known method is fuzzy C-means clustering. However, fuzzy clustering is less robust to noise and often generates unreasonable results. The condition sum UIK equals 1 is relaxed in possibility clustering. Each number UIK is interpreted as a possibility degree that object belongs to cluster. Recently, a new class of clustering methods called evidential clustering. It generalizes and unifies these methods and provides a more general and flexible framework. Evidential clustering not only considers the support of objects belonging to a singleton cluster, but also considers the support of objects belonging to set of different singleton clusters. Here we call the meta-clusters. Each cluster omega k represented by a center Vk, and each meta-cluster Aj represented by a center Vg bar, defined at the barycenter of the centers Vk for involved singleton clusters. And creditation generated by evidential clustering can provide us a flexible way to reveal richer information about the uncertainty and imprecision. Evidential C-means clustering is a classic method in evidential clustering. The objective function of evidential C-means as follows. The absolute value Aj is the number of singleton clusters contained in the site Aj. Alpha is the adjustable weight coefficient of the distance between object and the cluster center. Beta had the same meaning as in fuzzy C-means. Delta is the distance threshold for the noise cluster, and M is the belief degree, and the objective function of ECM can be minimized with respect to M and V using an optimization scheme. Here, we use synthetic data to illustrate the advantages of evidential clustering. We can see that the object axis is in the overlapping area of two clusters. In fact, it is difficult to be accurately assigned to a singleton cluster, and also X12 is very far away from other objects, so it is considered noise. It can be seen from figure B that FCM cannot accurately divide X6 and X12, which is due to the limitation of Faraday partition. Instead, ECM assigns X6 to meter cluster and X12 to noise. By doing so, ECM can not only reduce the risk of misclassification, but also will characterize the uncertainty and imprecision in the results. But today, with the development of information technology, we are often faced with multi-view data represented by multiple sources, by different features. For example, an image can be expressed by multiple feature descriptors, and in such situation, the above clustering methods will no longer be applicable. To solve this problem, many multi-view clustering methods have been developed. Although they have achieved reasonable results to some extent, they cannot represent the imprecision in the clustering results. In fact, uncertain and imprecise cluster structure is very ubiquitous in applications. That is, the cluster information of some objects is difficult to distinguish. So how to characterize the uncertainty and imprecision of multi-view data in cluster assignment and improve the clustering performance is an open question. So in this work, we propose a new adaptive weighted multi-view evidential clustering we called WMVEC for short. Specifically, we introduce view weights to capture the different contributions of each view in clustering and employ entropy regularization to regulate the distribution of view weights. Actually, WMVEC can be viewed as the counterpart of ECM for multi-view cases. Here are the optimization results of different variables, and the detailed proof can be found in the original paper. And next, we move to the part of experiment. In this experiment, we show the ability of credit partition in WMVEC on Aries dataset. We split the Aries dataset into 3 views by different features. And we can see that omega 1 is clearly distinguished from omega 2 and omega 3, but omega 2 and omega 3 are partially overlapped. And view 3 is much easier to distinguish between omega 2 and omega 3 than the other 2 views. From figures, we can see that WMVEC can clearly characterize the imprecision and uncertainty of cluster assignment. It carefully assigned indistinguishable objects to relevant meter cluster. And what's more, the parameter alpha determines the size of the meter cluster. A large alpha tends to correspond to lower imprecision and higher error, and vice versa. In applications, alpha should be adjusted according to the specific situation or user preferences. And in the following experiments, we take alpha equals 2. And next, we show the clustering results of WMVEC and the other methods on real-world design. We can see the proposed WMVEC achieves better performance compared to other methods, and more important, WMVEC with interpretation can offer deeper insight into the data. It can effectively characterize the uncertainty and imprecision in cluster assignment and avoid the risk of misassignment, which is very valuable in some cautious decision-making applications. And finally, we also tested the parameter alpha and lambda. We can see that the results with different parameters alpha and lambda have a significant impact on the performance of the WMVEC, and for each data site, the WMVEC can obtain better results if appropriate beta and alpha can be selected. And now we come to the last part. We firstly make a conclusion. Inspired by the functions, we propose a novel WMVEC method, which can express the uncertainty and imprecision in clustering results, and we design the objective function of WMVEC and obtain the view weight, cluster center, and quantification in an optimization way. We conduct extensive experiments on several real-world sites to verify the performance of WMVEC with other related methods. And in the future, we intend to extend the proposal method to deal with mixed types of data as well as incomplete data. That's all for my presentation. If you have any question, please feel free to contact me. Here is my email address. Thank you.